Hi, today's lesson is called Parallel Lines and Proportional Parts. It says proportional parts within a triangle. In any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. This is the triangle proportionality theorem. The converse is also true. If XY, so that's this segment, is parallel to RS, which is this one, then RX, let's put an A here, over XT, so that's B, A over B, is equal to SY, so we could call that C, over YT, which is D. So you can set up a proportion where you make a fraction on one side and set it equal to a fraction on the other side if you know these are parallel lines. Also, it says if X and Y are the midpoints of RT and ST, then XY is called a midsegment of the triangle. So this would be a special vocabulary word if we knew these two segments were equal and then these two on the opposite side were equal. The triangle midsegment theorem states that a midsegment is parallel to the third side and half its length. So if you know the length of the long side on the triangle that runs parallel to the midsegment, you just divide it by 2 to get the length of the midsegment. Or similarly, you could take the midsegment and double it to get the length of the long parallel side to the midsegment. Okay, so let's go down and see how all of this works out in our problem solving for today. So it says, we're going to start with number 2. We have 20 and X, and we have 18 and 9, and we have parallel lines. So we set up fractions. This left side will be one fraction, so it'll be 20 on top of X. I like to just set them up the same way that you see them in the problem. And then that's going to equal, on the right side, 18 over 9. So the 20 is on top in the problem, so I put the 20 on top in my proportion. X is on bottom in the problem, so X is on bottom in my proportion. So I just set it up pretty much like there's an equals here and draw the division bars in. So now we solve by doing cross multiplication. So we're going to do 20 times 9, which is 180, and then 18 times X, 18X. And then we divide by 18, divide by 18 to get the X by itself. So X equals 10. And that's the answer for this piece right here. Okay? All right, on number 3, notice we have tick marks on the left and tick marks on the right. That means that this segment where the X is the mid segment. And we just talked about a moment ago how the length of the midsegment can be found by taking the long side that's parallel to it and dividing it by 2. So 35 divided by 2 will equal X. Okay, if they had asked me to find the long side and gave me the midsegment, I would double that. But we're working to get the smaller one, we divide. So 35 divided by 2 is a decimal, it's 17.5. So that's how long the midsegment is. Okay, next we're going to go to number 4. So again, I'm going to set this up. I can pretend like there's an equals in the middle of the triangle and go X above 24 equals 10 on top of 30. And we can cross multiply, so we get 30x equals 24 times 10, which is 240. Divide by 30 on both sides. X is equal to 8. All right, the next two involve a little bit more algebra. It has on number 5, the left side is going to be x on top of x plus 12. The right side is 11 on top. They didn't tell us how long the bottom was, but they did tell us that the right side is 33 altogether. So if you take 33 and you subtract 11 from it, that's going to leave you with 22 for the bottom piece. So that was a little extra step they make you do on this one. So now we can cross multiply. 22 times x is 22x, and on the right we're going to go 11, and the part with the plus has to go inside parentheses, x plus 12, because the 11 has to distribute and multiply to the x and to the 12 as well. So we'll have 22x equals 11x plus 132. And now we're going to get the x's together, so we'll subtract 11x on both sides. 22x minus 11x is 11x, and that equals 132. So then we're going to divide by 11 on both sides to get the x by itself, and that means x is 12. And definitely feel free to use a calculator to do that if you want to. All right, number 6. Here I've got the x on top of x plus 10 equals 10 on top of 30. So you might want to pause your video and give it a shot, and then come back to the video and check to see if you got it right or not. All right, hopefully you have had the opportunity to do that, so I'm going to go through this so you can check. 30x equals 10 times x plus 10. You distribute the 10, so 30x equals 10x plus 100. Then you subtract your 10x on both sides to combine your like terms. So 20x equals 100, and then you divide by 20 on both sides. So x is equal to 5. That's the answer. I hope you got it right. Okay. The next part that we're going to do is proportional parts with parallel lines. When 3 or more parallel lines cut 2 transversals, they separate the transversals into proportional parts. If the ratio of the parts is 1, then the parallel lines separate the transversals into congruent parts. All right, so these problems look quite a bit different from some of the ones we've done earlier. So for number 1, what you need to understand is that these parallel lines separate these 2 transversals into proportional parts. And there's more than one correct way to set up the proportion, but that doesn't mean any way you could set it up is correct. The way I like to do it is I just like to pick a line, like one of the transversal lines, and follow the numbers along it. So like if I started with this bottom line, I'd go x plus 12 goes with 12. And I went left to right the same way that you read, equals, then I'm going to jump to the other line. Left to right, 5x goes with 3x, so 5x over 3x. Okay? I could have started with this line and said 5x over 3x equals x plus 12 over 12. That would have also been a correct way to do it. So we're going to cross multiply now. So I have 12 times 5x equals 3x times x plus 12. Now, 12 times 5x equals 60x. And then we have to distribute on the right. 3x times x. You might have not seen something like this since algebra. When you multiply x times x, what does that give you? X squared. So that's 3x squared plus 3x times 12 is 36x. Okay, so this is a little bit more of an advanced algebra problem. We're going to get the like terms together. X is here and x is here. So I'm going to subtract the 36x on both sides to get those together. 60x minus 36x is equal to 24x, and that is 3x squared. Now, I'm going to divide both sides by 3, so I'll have 8x equals x squared. And now, I'm going to divide both sides by x. These x's will cancel because x divided by x is 1. And now I'm going to do x squared divided by x, which cancels 1x but still leaves the other one. And that means x is equal to 8. And that one is done. All right, number 4. We're going to set this one up. I'm going to choose this line first. 5 goes with 8. 5 over 8. I'm going top to bottom. Y with y plus 2. Y over y plus 2. So now I'm going to cross multiply. 8 times y is 8y, and then 5 times y plus 2. So I'll distribute the 5. 8y equals 5y plus 10. And now I need to get my like terms together, so I'm going to subtract 5y on both sides. 8y take away 5y equals 3y. So 3y equals 10. And then to get the y completely by itself, I'm going to divide by 3 on both sides. So y is equal to. Now if you go to your calculator and you type 10 divided by 3, this is not going to come out evenly. It's going to give you 3.33333 repeating. So be sure to read your directions if you have any rounding instructions. Normally we're probably going to round to the 10th place, so just one number after the decimal, which would make it 3.3. But again, just be sure to read directions about rounding. All right, we're going to do one more of these type, number 6 here. And I'm going to start with the top line. I'm going to go left to right the same way I read. 16 over 32 equals, bottom line, left to right, y over y plus 3. And I'm going to cross multiply. So 32y equals 16 times y plus 3. Distribute the 16. So 32y equals 16y plus 48. Let's get this down a little. I'm going to subtract 16y on both sides to get my y's together. So that's going to leave me with 16y equals 48. And then I'm going to divide by 16. So y equals 3. 48 divided by 16 is 3. All right. Now, the next set of problems we have to look at is parts of similar triangles, special segments of similar triangles. When two triangles are similar, corresponding altitudes, angle bisectors, and medians are proportional to the corresponding sides. Okay? So we can set up proportions even when we're not just looking at the sides of the triangle. Sometimes they're going to give us some measurements for the special segments in the triangles, like the altitudes, angle bisectors, and medians. And we can set those up in our little proportions, little over big equals little over big as well. So I'm going to do this, little over big equals little over big. Okay, match up the matching parts. So on this first problem, number 1, I can go little side x, which is not actually the side of the triangle. Okay, this is a median because it connects a vertex to the midpoint of the opposite side. So the median x on this little triangle goes with the median 20 on the big triangle. And then the bottom side 18 on the little triangle matches up with the bottom side 36 on the big triangle. So that's how we set up the proportion, and then we can solve it as usual. Cross multiply. So 36x equals 20 times 18. And of course, 20 times 18 equals 360. So 36x equals 360. And then to get the x by itself, we divide by 36 on both sides. So x is equal to 10. All right, let's go over here to number 2 now. On number 2, we have angle bisectors, okay? This mark and this mark show that this line separates the angle into 2 equal angles. So I'm still going to go little over big equals little over big. Little angle bisector 6 goes with big angle bisector 9. Then I'm going to set that equal to little side x, which goes over big side 12. Okay, so now I'm going to cross multiply. 9 times x equals 6 times 12, which is 72. And now I'm going to divide by 9 on both sides. So x is equal to 8. 72 divided by 9 equals 8. All right, so we did a median problem. We did an angle bisector problem. The next one we're going to look at, number 3, is an altitude problem. See the right angles? Those are altitudes when you connect a vertex to the opposite side or the line containing the opposite side at a 90-degree angle. So little altitude x goes with big altitude 3. Little side 3 goes with big side 4. And now we're going to cross multiply. So I have 4 times x, which is 4x, equals 3 times 3, which is 9. And now to get the x by itself, I'm going to divide by 4 on both sides. So x is equal to 9 divided by 4. 4 doesn't go evenly into 9. It comes out to 2.25, and the decimal just stops there. It's 2 1/4. So I'm going to go ahead and write both decimal places down since it doesn't go beyond that. All right, that finishes up that page. We have one more to look at, which is called the triangle angle bisector theorem. An angle bisector in a triangle separates the opposite side into 2 segments that are proportional to the lengths of the other 2 sides. Okay, so let's look at number 1 here. What I like to do on these problems, when you see the angle bisector drawn, and they don't give you measurements, we don't have 2 triangles, so we're not going like little triangle, big triangle, is I like to take that angle bisector and just, I'm using a highlighter here to draw a line that separates this into 2 separate parts. And now what I'm going to do on the 2 separate parts is I'm going to just make a fraction here and make a fraction here with an equals in the middle. So I'm going to go left side is 25 on top of 20, and right side is x on top of 28. So it's like I just put a division bar here and a division bar here and an equals in the middle. And this is setting it up because the sides and the bottom side split into proportional parts. So now we're going to cross multiply. 20 times x equals 25 times 28. And 25 times 28 is equal to 700. So if I divide by 20 on both sides, x is equal to 35. All right, let's take a look at number 2. Again, I'm going to take my highlighter and just draw a big line here. This separates my problem into 2 parts. I'm going to put a fraction bar here, and it equals in the middle. So it's going to be 15 over a equals 9 over 3. And now I can cross multiply. 9 times a is 9a. And then 3 times 15 is 45. Divide by 9 on both sides. A is equal to 5. All right, let's look at number 3. This one is a little bit more complicated. It's going to involve a little bit of algebra, okay? I still am going to think of this line as splitting it into 2 parts, but if you look at the left side, I don't know what's on top here. There's nothing here. They give me the big long piece is 46.8, and then this side is an n. So this part would be 46.8 minus n. Take the big minus that part, that gives you what's over here. So with my fraction, my proportion is going to have 46.8 minus n on top of 36, and that will equal n on the right on top of 42. Okay, so now I'm going to cross multiply. So I'm going to have 36 times n equals 42 times, in parentheses, because of the minus, I have to put that part in parentheses, 46.8 minus n. Now I'm going to distribute the 42. So 36n equals 42 times 46.8 gives me 1965.6 minus 42n for 42 times n. I need to get my like terms together, so I'm going to add 42n to both sides of the equation. 36n plus 42n equals 78n. And then I'm going to have 1965.6 left here. I'm going to divide by 78 on both sides, and definitely punch this in your calculator. 1965.6 divided by 78 equals 25.2 for n. That was a bit of a doozy. Now let's look at number 4. And this will be the last one that we do today. We have this lines, the angle bisector, separating it into 2 parts. X on top of 10 on the left equals 13 on top of, we don't have a number here. So we're gonna go 15, the bottom side, minus 10, that leaves 5 for this part. Okay, now that we have our proportion set up, we're gonna do what we're getting really good at, cross multiply. So 5 times x equals 10 times 13, that's 130. And divide by 5 on both sides, so x is equal to 26. Okay, that concludes our lesson for today. I hope that you have a great time doing your homework. If you have any questions, please either email me or come in for tutoring. I'll be happy to help you. Have a wonderful day. Bye for now.